Doing an audio test. Okay. Can I get a woo woo? You can get a woo woo. I'll even do this for you. I'll throw that in for free. Woo woo. How are you getting on? Can you hear me? Actually, I managed to mute the microphone last time I was doing this. Tell me you can hear me. Yep. Okay, good. I will deliberately mute myself so I don't slurp my coffee. And wait a minute to see if people show up. Yeah, okay, so a recap of last time. I think I suggested what you should do when you're learning something is make a set of folders. I like to do this. I think it works really nicely. And it's easy for you to say, here's my to-do list of like, hey, this week make a list of all the features you might want to learn and then make a folder for each one. And then each week do one or two. So last time we did the first stream, we did a Hello World program. It's been ages setting up a compiler. Last time we talked about variables and functions. And this time I'm going to talk about loops and arrays. So I have a function for the folder for that. And I've just made a new main.c. So like the other thing is with a video or a stream, you just don't have enough time in spoken format to go through all the particular little rules for each feature. So it's definitely worth getting a book or a website that will list all of the particular cans and can't do's for each thing you're doing. I certainly don't want to go through and exhaustively do that. But an example of that is variables. So last time we did assigning values to variables and using variables instead of just using the values directly. And we used variables as inputs to a function in a parameter list. But there are other things you can do when you create variables. So I like to start with a hello world first of all, just to make sure I got everything set up working and I haven't broken my compiler since last time. Okay, no, not. Okay, I'm missing the. So it's saying, hey, you've used printf, but I don't know what that is, so you've got to include that header. So this was the first tutorial, was just setting that up. Not standard int, standard IO, input output. Okay, and then I should be able to go, hey, hello world. Okay. Right, so when you're making a variable, I can make one up the top here, and I can say the type of my variable is int, and I'm going to call it, the name is my variable, and I'm going to directly assign it a value of 10, and hello world, and I'm going to say my variable is percentage I for an integer, and then if I go comma, the percentage I was a placeholder, if you recall, then I can use my variable name to print my integer variable. What's it complaining about? Nope, that's all right. Okay, so it said down the bottom there, hello world, my variable is 10. So that's perfect. It is printing out here the value that's stored in the variable. So there are a few caveats there I didn't mention. When you're naming your variables, you can call them anything you want, but they cannot have a space in them. So I can't say my space variable. That won't work. It thinks that's two separate tokens then. So in lieu of a space, I might have mentioned this, you can use an underscore or run both words together. Maybe you can make one a capital. So you have some options like that. Just have a consistent style. And remember that capital letters are treated as separate letters in the ASCII table. So try and keep everything lowercase if you can, or at least have some rule there. You also cannot start a variable name with a number. So you can't have my variable. See, it's complaining straight away there. But the text editor knows there's something wrong with that, so it's making it red. You can put a number anywhere else, though. It just cannot be the first character in your name. So you've got a long list of rules about how these things work. What I did do that didn't explain was we used variables a few times like this, but there's actually a couple of things I'm doing there. I have a variable declaration, which says my variable name and its type. So those two together are called the declaration. But on the same line, I've done something else as well, which is initialize the variable to some starting value. I've assigned a value to it and declared it on the same line. And if you can do that, that's a good idea to always do that, because it gives some default value to things. If you don't do that, and you forget to ever initialize your variable, what value is in there? And that's a very good question, because I don't know. It's whatever was in memory wherever it's created your variable before. So if I try and print that, I don't know what the answer is going to be now. And it's a very common source of error in the C programming language. So it said, hello world, my variable is 0, but there's not any guarantee actually that 0 will be in there. If I run some other program and then run my program again, I could get a different value printed out there. So there's no property in the C programming language like there is in other newer languages that sets some default value like 0 in your variable. So it's something to be very careful about, is always make sure either right away when you declare it or immediately as soon as you possibly can assign some value to it. So there I've done it in two separate lines. I've declared a variable and then initialized it, which means assigning the first value to it that you use straight away. But you can actually do those and combine them in one line, which is pretty handy. If you have a line somewhere in your program and you're wondering, why is it not calculating the correct answer I was expecting, just go and check all your variable declarations. So those are a few things I didn't go into detail about, but you would need to know all of those little caveats and tricks and traps And you will find more of them by experimenting with things, but really I don't have time in a video to go in detail for all of that. Yeah, that was the first thing that jumped into my mind anyway. Okay, so in older versions of C, when you declared a variable, it had to be at the top of a function or a block, which is what a section with these curly braces is called. You had to declare them all at the top. Um, one of the advances C++ introduced was that you could have declare anywhere variables. So I couldn't, for example, have printf. Sorry, I couldn't have this. I'll put that back. I couldn't have that and then further down have another variable declared below a function call. So I couldn't say Anton equals 10 down there. I wouldn't be allowed to do that in C89, 1989 version of the C language. But in newer versions of C, you can. It's called declare anywhere variables. So that was actually something C++ introduced, which is one of those quality of life features. So if you see anyone that uses C89 code, and that's quite common for libraries actually, because it's very easily portable. It's still all valid C++. As well as C. So if you want to make something that's easy to share, do it in C89. It's your widest possible supported language, probably. You will see people do funny little things like, oh, they don't actually need this other variable until much later, but it's painstakingly declared up the top. So you put all your declarations at the top of the block. You don't need to do that anymore. I wouldn't bother. Just do it where it's convenient. You cannot, however, use a variable before you've declared it. So remember that we're proceeding in execution and also the compiler parsing line by line. If I try and declare my variables below where I first used them, the compiler is going to complain because it doesn't know what they are yet. So it said my variable undeclared. So you need to do that on a line above where you first use it. So I can do that by moving it up above. Okay, you can, of course, assign a value to it anywhere after you've declared it. So I could, down here, say my variable is now equal to 11, and it replaces the value 0 that the variable holds with another one. So that's okay. So these are all the little issues with variables I didn't get into. But there are rules like this with everything. So every feature has these things. You need to do some due diligence and go and look up all the funny little workarounds and things you need to know about. Okay, so we did functions as well. And what I'd like to talk about today is arrays. And we actually already have an array in Hello World. It just may not be obvious. So we talked about strings and how each character in a string, each letter is called a character. And that's a data type actually in C. So a char is one of our data types we have available and built into the language. So hello world is actually a series or a string, you call it when it's a series of characters, each 1 byte large and corresponding to a numerical code in ASCII. So they're displayed here as words, but internally they're stored as numbers. So the capital H has a value. Actually, I've got my variable written in there. The little letter A has the value of 97. So if we printed out A as an integer, it would print 97. And I think we did that in the first. So I'll print a space and then the value of the character A. So actually, you know what? I can make a variable. So let's make char my letter, and I'm going to call it A. And when we want to indicate the character A, we put these single quotes around it. So a string or a sequence of those, double quotes, quotation marks, but the apostrophe on either side, or single quote, you call it for just one letter. So that will print out, if I say %i for the integer value and then give it this variable name, it should print the ASCII value. And it said 97. So that's what we looked up, if you recall, last time in the ASCII table. Right. You can also print the character value of this char, just one character on its own, by putting in a %c. So if you look up the manual page for printf, it'll tell you what all the different codes you can put there for different types. It doesn't have one for every type, but it has quite a lot. And if I print that out instead of with a %i, it's now, and it may be a bit small in my terminal there. I wonder if I can make that bigger. Console font family. Okay, let's put that 18. Did that do anything? I'm not sure. No, it didn't seem to do anything. Console font size. I feel like that's exactly where the font should have been bigger. Didn't seem to do anything though. Let's kill both of those consoles and make a new one. Nope. Okay, what if I just zoom in? Will that work? Oh god, not really. Okay, so the perils of making software based on a web browser. And now I don't know how to make it go small again. Okay, I don't know how I'm going to zoom that in more. There must be a way to do that. Like it feels like that's the right space. Maybe if I put terminal instead of console. Terminal font. Oh, maybe this will work. Yeah, terminal. Okay, it's not a console, it's a terminal. Okay. So I'm going to type in clear to get rid of that stuff there in my terminal. Oh, thank you, Shane. So if I type in gcc main.c, I'm in the wrong folder. Okay, if I now execute it, hopefully you can see that a bit better, but it said hello world, my variable is space 0 for this value of that variable I was printing before, and then the character A as a letter. So I've put %c to do the character, same variable, different way of representing it. If I print it out again as the value, it prints 97, which is the ASCII value. Okay. So each one of these things is a single character, but if I have a whole sequence of things that I want to print, you call that, if it's a sequence of characters, we call that a string. If it's a sequence of any other data type, so integers or booleans or anything else, we call that an array. So if there is a whole sequence of characters, such as in hello world, it is called a string. And this is C terminology. So other languages have different ways of representing things they call a string. But if it's literally just a selection of characters all contiguous one after the other in memory to form a sentence or a phrase or a series of control codes, we call it a string of characters. Anything else is an array. If there is a whole sequence of integers, it is called an array of integers. Okay, so let's make a sequence of characters. And the way we can make, they're the same thing actually. So a string and an array are the same thing in C. It's just one is specific to characters. So let's make an array of characters. And I'm going to call it char. So the data type is a series of chars or characters. My string, so this is a variable name you can call whatever you want. And you need to say how many characters are in your string. So I'm going to give it, let's see, Anton. So my name requires 5 characters. And strings in C have another special character, which we haven't looked at yet, at the very end, called the Null Terminator. We might come back to that in a minute. So if I want 5 characters just to store A and N and T and O and N in it, I can say, okay, I want 5 characters. So I've got these square brackets to say an array of these things. Okay, so I've declared that, so my string. And then what I might want to do, the simplest way of doing this is we could do it one character at a time and set my name into it. So we could say, okay, my string, let's set the first character in my string. We're going to assign it the value of A, like we did up here with my letter equals A in single quotes. So we're going to do the same thing, but set the first value. So what you do to do that is open your square brackets and then give it the number of the thing you want to set. So I'm actually going to give 0 because C starts counting at 0, not at the number 1. So number 0 is the first thing in the string, and I'm going to set that to A. So actually, what we're doing here is what we want to finally achieve is, if you imagine square bracket, this is just a comment, if you imagine the square brackets being each character, they don't mean anything, I'm just using them as a separator here. So what I want to set is the first character to A, the second to N, the third to T, the fourth to O, and the last one to N. Okay, that's as far as we're going to go so far. And the number of each one is, it starts at number 0, starts at then number 1, then 2, then 3, and then 4. So we've said that the length is 5. Is 5, right? So the last one isn't actually number 5, it's number 4. So I'm going to say I'm just copy pasting lines here. 3 and then 4. So I'm going to say A, N, T, O, N. And that is what you're doing there is setting the individual characters. And these are all actually going to be contiguous in memory, right? So these characters are going to be one after the other in our computer's memory somewhere. We can guarantee they're all going to be, so if this starts at some address on the computer, this will be 1 byte later, this will be 2 bytes later than the first one, this will be 3 bytes later, this will be 4 bytes later, right? So that's the nice property of arrays, is all characters here sit next to each other in memory, so they're contiguous. And then what we can do is print that out. And I think printf will let me just use this. Instead of having a string inside quotes and giving it directly, I think it'll let me just delete all of this and just give the value of my string. Now that's going to print something crazy if it works. It worked, actually. It didn't print anything crazy, which is kind of lucky. So that printed out not just one character, it printed the whole lot, which is kind of nice. So the problem you've got with strings in C is that we've given printf, when we said print my string, we haven't told it how big it is. It doesn't know. It doesn't have this information to say that it's only 5 characters long. And it's the same for any array. That number isn't stored anywhere. So in newer languages, when you create a list of things, like an array or a string, you will create it. You might say how big it is, but internally it would also have some variable automatically created that says how long it is. We don't have that. So when we print it, it doesn't know where the end of the string is. And what I was expecting to happen, but it didn't, is that what happens when printf sees this array of strings coming in, it'll go, okay, or an array of characters in a string. What it'll do is it'll print the first character wherever the start of your memory is, so it knows to look at index 0 first. Print the first one, move to the next one, print that, move to the next one, print that, move to the next byte, print that, move to the next byte, print that, and it doesn't know to stop. So ordinarily, if you try and print a string out and there isn't anything at the end here to say stop, it will keep going in memory until it runs out of space. And that is a major problem with these basic functions in the C programming language, is if you forget to tell things when to stop, they will keep going and they will print whatever was in memory at that point, and they will go and go and go. And all of these string functions that you will use have that flaw in them. So we need to remember to tell it how to stop. And the C mechanism for doing that is to add another character on the end of the array, which has a special code. It's also in the ASCII table. We might have mentioned it. It is the null string character, and it has a special character code, which is \0. So that is the Null Terminator, which means end of string, right? So all your string functions expect to find this on the end. We actually have a bug in this program if I compile it now, because I have put this on the end here and I've said /0. Now that is not a printable character, so it'll never show up in your printout. It's just an indicator to a function that accepts a string that this is the end. And what I've done here is I have used memory that I never allocated. So I didn't ever declare that my string was going to be indexes 0, 1, 2, 3, 4, or 5, because that is actually change the length of the array. I'm now requiring an array of length 6. So it might actually complain if I compile it. It hasn't said anything, and this is another danger with C, that it's allowed me to use memory I've never requested. So something else might actually own that memory, and now I've got a conflict with two different things writing to the same memory. So what you need to do there is actually turn on your warnings, and it should tell me. If you remember, there are some command line flags to do this. Wall, extra, pedantic. Hopefully it'll tell me. And it has. It said warning. Oh, unused variables. That's fine. Unused variable Anton on line 41. So I can get rid of that. And letter A, get rid of that. And I think my variable, so I can get rid of that. And let's compile it again. So it's an error. My variable undeclared. Oh, I can get rid of that. And no, it hasn't complained. So that's a real problem. And there is a tool that I was going to show you perhaps in another session called a linter or a code sanitizer that will go through and look for these things your compiler will miss. I don't have the clan compiler installed. I think that does a better job of finding these things. But GCC is the compiler I'm using and it doesn't see the problem, which means I'm reading and writing memory I don't actually own or have access to. So what you need to do there is go back to your string and go, the length is now 6. So if I run this again, okay, so it's printing correctly. That's a sneaky little trick that you need to remember with arrays of characters or strings you intend to print, is that none of these functions know where they end. A different way of doing that would have been to create and you'll need to do this with other arrays, is create another variable that stores the length of the string. So my string length equals 6. And if I had written string processing functions, it wasn't me, I would have done, I don't know, Anton printf would have looked like this. My string, and then maximum characters to print would be my string length, right? So I'd take two inputs, the actual array, and then you wouldn't need this concept at all. That's how I would have done it. But that's not how anyone else did it. The downside is it means instead of just one extra byte to drag around with your string, you need a whole extra integer, which is 32 bits or 4 bytes. So that's not super handy, but a bit of a weakness. If you're making another type of array, like an array of integers, you will need to have another variable somewhere to record the size of your array. It's not something you can ever get back from here. So I was going to talk about loops as well. And now that we've got a sequence of things, okay, what if, rather than just print the whole string at once, what if we wanted to print one character at a time? So what we could do, as you might recall, is go printf and give it %c for a character, and then go my string 0, my string 1. So we could do it the tedious way like this, right? You could make separate function calls. Or within one string, you could do multiple individual characters. So I could say, well, let's do a separate thing for that. Down the bottom here, we could say the first character, comma, or space, or both. Second character, the third character, the fourth character, and the final character. So down here, I could say, okay, the first placeholder is my string 0, then 1, and you can have these any order you want. 2, 3, and then finally 4 with no comma at the end. Okay. Let's compile that. Okay, so I might need to put a line break in between these things to separate them out from the other prints. Okay, so it said Anton, which is this thing we printed here with printf, the whole string, and then Anton all together, because I printed one character at a time there from the array or the string. And then finally, we printed one at a time with some formatting, and it's actually split that up for us down the bottom. So those are your options, but it's a little bit tedious accessing individual characters like that from an array or from a string. So what you could do is use a loop. So your basic type of loop in C is called a for loop. So what I'd like to do is say, starting at number 0 or index 0, when you're accessing one of the things in an array, So that's the length of the array where we've declared it. But these here, these numbers here, where we're accessing individual elements in the array, that's called the index. So index number 0. So index numbers, and the plural of index is indices, or indexes if you prefer. So when we're using an index like that, wouldn't it be nice if we just had some simple way of saying, okay, start at index 0 and go up and inclusive of index number 5 and one at a time call printf. And instead of using 0, 1, 2, 3, 4 manually, we could give it a variable that just says the current index. And you can do that with a loop. So C has a thing called a for loop, which will let us do that really easily. So we use the keyword for, which is another built-in keyword, and you can see the text editor can see that it's a keyword because it's colored it in purple. And then open round bracket or parentheses, and close round bracket of parentheses. And inside these, we're going to put our condition for how many times it's going to loop, where it's going to start, what number we want it to start at, where we want it to stop. You can put anything you want in there. We'll do that shortly. Then you open a brace or a curly bracket and close a brace. So inside the braces, that is where any number of statements in C can go, or instructions, any number of instructions that should happen on every, and the keyword there, or the term there is iteration of the loop. So at each index, what do we want to do? We just want to call printf, but you might want to do other things there too with that number. That's okay. You can separate them as per normal with lines of code. So we have the keyword saying for, and then inside here we have the conditions of looping. Where to start, where to stop, how to check if you've finished, and what to do at the end of every, put that above there, what to do at the end of every iteration, right? So we have 3 condition statements in there, I guess. So the first thing is, where do we start? And we want to start at index number 0. So you have three kind of terms inside your condition that are separated by these 2 semicolons. So they're kind of like lines of code. So the first thing I want to do in there is say, okay, I want a new variable. It's going to be an integer just to hold my index values. So you can see that these index values are whole numbers. They're essentially integers. So I'm going to create an integer, and your typical example for loop uses an integer called I, because it looks like a mathematics notation whenever you've got a sum with the sigma, the big letter E looking thing from Greek, the sigma. You'll use the variable named I to say the count at each iteration of your sum. So echoing that in programming, you usually use the letter I. So I'm going to create a new variable called I. And in modern C, you can declare and assign it right in there in the same place. And I'm going to start it at, assign it the value of 0. So that's the starting condition. That will be set up once when you enter the for loop. It won't happen every time you iterate over every step. Okay, the second thing is, when should we stop? And I want to stop, I want the loop to keep going whilst the index is less than the number 5. If it ever gets to the number 5, I've gone off the end and I want it to stop, right? So while I is less than 5, I don't want it to do anything on this null terminator that I've assigned here. So I'll skip that one. I want it to go 0, 1, 2, 3, and 4. So while it is less than 5, you're allowed to keep iterating the loop. If it ever is equal to or greater than 5, it'll stop and it'll exit the for loop down the bottom, and the control flow will continue with the rest of your program. And the last little term in there of the 3 terms inside our for loop condition is, what do you want to do at the end of each iteration? Not at the start, but at the end. So the first time I iterate through this for loop on whatever I've got in there, I want it to use the number 0. The second time, I want it to use the number 1. The third time, I want it to use the number 2 for my I value or my index. So after I've finished with the number 0 and before I start the next iteration, I want it to increment, which means add 1 to the value of I. So I could say I equals I plus 1, but there is a shorthand for doing that in C, and that is another operator. So it's not this operator anymore, it's plus plus. And that will increment the value of I. So you can use that anywhere in your code by the way. So if you have an integer somewhere in your program, you can, instead of let's do that separately. So I can say int my value equals 0. Anywhere in your code you can write int my value plus plus. And what that will do is the same as my value equals my value plus 1. So if I printed out my value now, it should hold the value of 1. Okay, so what I'm saying is I'm entering a loop. I want you to keep repeating and starting at the top of the instructions in here over and over again until this condition is no longer true. So, and after every step, so the I++ happens at the end of each loop iteration. At the end of each loop, add 1 to I. And this is the starting condition, that I starts set to 0. Okay, so what I want to do inside here, we're just going to add one instruction, printf, and I will just print. Oh, you know what we can do? We can print the number, the index, or the number of the iteration. I equals %I. Okay, so I'm saying print the letter I literally, and then the value that I've stored in the variable I will go here in this little placeholder. So this I has nothing to do with this I, it's just a coincidence. I could have put D there for the decimal numbers, which is another kind of unfortunate term for integers. So you can use %I or %D to print an integer, it doesn't matter. I usually prefer I because it starts with I for integer, but older code, or in fact the original programmers, tend to use %D. So I'm just saying my variable code I is equal to this value. I'm going to print that every time it iterates. And what else were we going to print there? Oh, the character in my string, and you know what, I'm going to put %D there again, is equal to, and then %C for a character. So I don't know if you're following everything I've got in there, but what I'm trying to do is say I equals, at the start, on every iteration, it's going to print I equals, and then the value of I, so it should be 0 the first time, 1 the second time, 2 the third time, and then following that, it'll say the character in my string. And this isn't actually accessing the variable here. It's just that you could put anything here. I'm just typing it out to remind myself. You know what? I'm going to say that, my string. And then I want to say at which index, so I'm just going to print the same value again here. Inside the brackets, and then finally print the actual character that's stored in there. So this might be a little confusing or a little clunky, but why not do it like this? So the first placeholder, I'm going to use the variable I. I want that value to print out there, and then comma, and then the second placeholder is this one here, and I'm just going to use I again there. I probably didn't need to write that out twice, but okay. You can do that any way you want. And then the last placeholder there is %C for a character, and I actually want to print out my variable. And then when I index it, I'm not going to use 0 or 1, I'm going to use the variable I, which should hold that value that I need in there. Okay, so I've got one of these commas and a variable matching every placeholder, 1, 2, 3. Just double check that, it's easy to forget something. And then you get weird results when variables get mixed up when you're printing. And then semicolon, and then let's compile that and see if that's okay. Let's comment out the other printfs, just so nothing gets mixed up in the printout. Okay, so here we go. Here is our loop iteration demonstrated. So rather than tediously typing printf out over and over again, we've said loop over printf and do this for this many times. And then you can actually use this variable that you've used to count how many times you want to iterate, and you can use it inside the for loop. So it is said the first time, I equals 0, which is what we wanted I, the index, to start at. The character in my string at index 0, at I, is equal to, And then what I've done is used that variable to index my array or my string. And I've said at index 0, and it's gone away and looked up the value at index 0, which is this one here, and printed that character in character format for us. I could actually have put %i there, and it should actually print out the ASCII numerical value instead. So remember, those are the same thing. One's just a different way of displaying those numbers. So it's actually printed out the ASCII there if I've gone %i. So I'll switch it back to %c. So there's my name. And you've seen it's actually done 1, 2, 3, 4, 5 printfs statements. So it's printed out 5 lines. And the second iteration was 1. Remember, at the end of each for loop. So our control flow, as we know, goes line by line. But actually, when you get to a loop, it will start at the first line in the loop. It will check before it actually enters an iteration, it will check if this condition is true. So it wouldn't do anything there if we put, I think, I less than 0, because it's never less than 0. So let's just try that. It's printed nothing. So before it enters the loop at all, the first thing it does is check this condition and see if that is true. And the first time we go through this condition, and remember we talked last time about doing a walk through your code or stepping through one line at a time and putting your variables down on paper. So you could do something like this. So we have this variable called I, and at step number, let's call it 0, we can start counting at 0. At step 0, I starts at the value 0. That's what happens first, right? And then what we do is we execute this printf statement on our first iteration because that was true in our condition. It will go and print that using I equals 0. Okay? And then after this iteration has finished, so when it gets to kind of the closing brace here, it will jump up and always execute what is in this third section of the condition part of the for loop. So the next thing it'll do is increment the value of I. So at step number 1, I is now equal to 1. So you can cross out 0 there, and on step number 1, I is equal to 1. Okay, then what will happen is it will check this condition again, and actually I is still less than 5. It is now equal to 1, so it'll enter the loop again, and we'll get down to the print statement again. And then, so I'm doing the walk that you would need to do if you're manually debugging your code, step by step. So now it's going to print this again using I at the value of 1, and that's the second line it's printed down here. I equals 1. The character in my string at index 1 is equal to n. Which it is if we go back and double check what we assigned up there. Okay, and then, okay, what's step number 2? Step number 2 is at the end of that iteration, we jump back up here again and fulfill this last part of the condition of the for loop, which is increment at the end. So step number 2 is I is now equal to 2. So I'm just going to write down a little reminder here of, oops, that's the wrong characters. How that works in the for loop. So we've got open parentheses and then initialize values. Okay. Happens at start of, okay, initialize values only when we first enter the enter the loop. Then we have a semicolon separating things out, and then it is if every at the start of every iteration, check this is still true. If not, exit the loop immediately. Do not pass go, do not collect $200. And then we have another semicolon, and this is this last part here. And after every loop, every loop iteration, complete whatever is here. So this is a very typical for loop. We've said int I equals 0. We've got some condition that says when to stop, at what number we should stop iterating. And then at the last section, we've said add 1 to I every time. You can put different things there, but this is a very, very typical for loop. Most for loops will look like this. It's just this number here will change to match your array. Okay. So in our little walk, we got down to step 2, and we've incremented the value of I to 2 at the end. Then we jump back up the top here, and according to this notes that I've just written down here, the first thing we do at the start of every iteration, we don't need to do this. This only happens when we first enter the loop, but we do this at the top of every iteration. So we say, is I still equal to 5? The value of I is 2, so yes it is. Now we can enter and do another iteration. So we'll jump the control flow back to here, and we'll go printf I equals D. So now it's going to printf I equals 2. The character in my string at index 2 is T, and it's printed that out correctly. And we can carry on like that. So at the end of the iteration, what happens? We do this always. So add 1 to I. So we can say subs3, I is now equal to 3. And then, of course, 3 is at the start of the next iteration. 3 is still equal to 5, less than 5. So we'll do another iteration, print that out, and at the end, jump up and do this again. I is equal to 4. And you'll see that it's printed 3 correctly with O, and so on and so forth. And finally, on the last iteration, we will increment I after printing out the fourth character N. At the end of that, we'll come back to the top, check if we're going to do another iteration. Is 5, which we have now incremented the value to, is that less than 5? No, it isn't. So stop doing the loop, put the control flow back to where it would normally be after the for loop statement. So we're basically jumping, checking a condition. If that condition is true, jump back to the start of for and keep going until that condition is no longer true. So that's how a for loop works, and it's a fundamental concept you'll use everywhere in all of your C programs. It has a nice feature that it's kind of, apart from the unusual ordering of this stuff and the conditions, once you get the hang of that, it's very easy to understand. And you have a nice ability to have variables up here you can use inside your iterations. So different kinds of loops in different programming languages don't have this anymore, and more modern languages have started to get away from this idea and make things a little bit simpler. But it's actually quite nice to have a counter like this, a variable that counts up you can actually use for things, even if it's literally printing out in your print statement, hey, this is iteration number whatever. Okay, so I know that's very verbose. I hope that makes sense. Does everyone follow that or have any questions about the for loop before we carry on to the next bit? So something we had with strings before, when we wrote hello world, we didn't have to make a variable and set every individual character like this. What we did was give what's called a string literal, which is a way of representing an array of characters immediately. You put your quotes together like that, and you can type whatever you want. You can put whatever control codes you want, and it will work. When you do a string literal, the null terminator is always magically added into the end. Oh, okay. So asking about the iterator at the end here. Any thoughts? Yeah, people like to argue about this. There's also a different type of iterator where instead of doing I++, you do ++I. Both of those will do the same thing in this context. So the difference between those two, and I can show you with an example. Let's get rid of that. Okay, let's do an actual difference between those two. So if I go int my value equals 0. Okay, and then let's print my value. Print incremented value equals. And then I'll compile that, and we're expecting what? We're expecting the value of 1, right? So it's printed incremented value equals 1. So that's correct. What happens if we do the other notation, where if we put the ++ on that side? Still says 1. So it's doing the same thing in both this context and for our for loop. You can see our for loop is still going to work if we switch that around. Okay, so it's still correct, Anton. If I, rather than print my value, what if I print, let's leave my value at 0, but let's actually put the plus plus down there. So let's print my value plus plus. Okay, what does it print? It prints 0. So that's interesting, isn't it? So when we're actually using this value, it's printing whatever it was already stored there and then doing the increment afterwards. So it's going to use this value and then do the increment. So another thing we could do is use another variable. My other value equals my value. Okay, so let's use my other value and print that. Let's get rid of the plus plus for now. Okay, so my other value should be the same as my value. We've assigned the value of another variable into this new variable. So I print that. Okay, my other value has got the value 0 in it. That's correct. What if we do let's actually say that down here. My other value equals this, and then comma my value equals %i. And then we'll put that down there because we've got another placeholder. Let's print them both out so we can see what's in both. So it said my other value equals 0. Okay, that's what we expect. And my value equals 0 as well. Okay, perfect. So they've all got this same value. What if I do this? My other value equals my value, but I do plus plus there. Let's try that. So that's coming back to that idea. So it said my other value is 0 and my value is 1. So what it's actually done there with this notation on the right-hand side, the increment on the right-hand side of the variable name, is it has assigned the previous or the current value that was in this variable here into our new variable, and then actually incremented this value, this variable afterwards. So there's like a one extra step of latency there. If I put this on the other side, okay, now what do we think is going to happen? So now they've got the same value, 1 and 1. So now what it's done is before using the value when it's in the same instruction or statement altogether, what it's done is first incremented this variable's value and then assigned it. So you have two options there. Does it really matter? There's occasionally a time I default to always using the post increment notation. So putting it after the variable name. I will always use this notation unless there is some special scenario where this is a nice handy shortcut for something that maybe saves me a line of code, right? So I will do that. Almost always I will have it in this format unless I specifically mean to have it the other way around. Does it really matter? Some people like to have in their for loops this way around. It doesn't matter. It doesn't make any difference for you at all. And I've seen debates about at the compiler level that's more optimal for performance. It's just nonsense. It is such a tiny, minute, debatable difference. Once you start arguing at that level, it's not worth considering. So and I've even seen people that write compilers come back to these people with a real strong opinion and say, no, that's not actually correct. Since we changed compiler to this version, that's not true anymore, and these kind of things. So don't worry about tiny, minute, secret knowledge like that. It's usually wrong. Do not worry about that at all. More modern languages like Go have solved these like questions by just explicitly not ever allowing you to have the increment on the left-hand side. It's not allowed anymore because it confuses people and creates arguments. So it has to be like that in the Go programming language. So that's my take on it anyway. You will, if you asked 10 random C++ programmers, they're all going to have a very strong opinion and they'll all argue with each other. So it's a great way of, if you want to get out of a work conversation at a work party, just drop that bomb and run away and they'll argue amongst each other for hours. So I don't think it's worth worrying about. Just pick one or the other and stick with it unless you mean specifically the other thing. And if you want to copy me, that would be my default. I think like something that's quite tricky with programming and something that you kind of have to learn the hard way is like lowering the amount of options and stuff that you have to kind of keep in the air in your head, that cognitive load, keeping that as low as possible is going to reduce the amount of mistakes you make. So if there is a choice to do some fancy feature or not, I will almost always choose not, unless it's a really exceptional scenario that warrants doing it differently, or using some fancy feature, which is probably the main reason I've gone all the way back to using C again in the first place, where I don't absolutely need to use C++, because I like to have my cognitive load as small as humanly possible. And I find that makes me a better programmer. Your mileage may vary between people, and that would really ruffle some people's feathers to hear that. But that's my take on these things anyway, that I've developed over time. Okay, so just gonna grab a drink here. Okay, so I was going to talk about strings again, and instead of manually setting each character in an array of characters, what you can do is do what's called a string literal. So what I could have done is said, instead of this, let's comment that out. I've got a big mess of commented out stuff here now, so I'll delete some of this shortly. What I could have done is said, okay, my string, I believe I can do it here on another line, my string equals. And then instead of just giving it one character, you see I haven't given it an index at all. I could say open quote, Anton, with a capital A this time, close quote, semicolon. It might not let me do that on a separate line. No. So I have to do it here where I declare it. Okay. Now that is at compile time. So the compiler, when it sees this, will make space to store 6 characters, so 6 bytes all in a row. And when it does that, it will also put these values in one at a time. So it knows that I'm giving it a string here, and it will set the first byte to A, capital A, the second byte, so index 1 will now be N, and let's try that and print it out. So it still works, and now I've got a capital A. So that's a nice way of setting a string literal. All in one go. Right. You could kind of do that with arrays, but not with the same notation, of course, because they're not printed characters. Okay. So in the same way that we did strings, we can also do an array of other things. We could have an array of integers that said, maybe you've got, so something we did recently was we had computer programming labs or practical sessions, and we had a class of 80 something, but only 20 something could fit in the lab. So we had to split it up into groups, and we had a sign up sheet, and it was on a spreadsheet, like a Google Sheets or whatever. And there are a number of slots marked out and like a line drawn underneath, so that basically once you put your student number in, and it got to the end of the third, slot number 30 or whatever, no one else should put their number. But of course people did, and they went over the line and they put their name on several different time slots for the it was a disaster. So you could make a program that didn't allow any ambiguity like that. It's like it could say, what is your student number as an integer? What time slot do you want to be in? And it would say, okay, this time slot is full, or you could go and look, and it could say you've already put your student number in one of the other time slots, so pick one and only one. So you may, if you're doing a program to do that management of lab bookings or something, you'd probably still do it in a spreadsheet. But if you wanted to make a C program to do that, you could make an array of student numbers for today's lab session. So you could say, okay, student numbers, and then how many students fit in there? Well, let's say the maximum is 30, right? And then you could start entering student numbers. So I won't actually let you type in this program, because that gets a bit convoluted, but let's just manually assign a few. So let's say student numbers. So the first student in the class is student number 0, and their student number is 1, 2, 3, 4. Something like that, right? So you can have an array of integers. It works exactly the same way as we were just working with. And the next one is 1, 2, 3, 5. Exactly the same way as we were working with strings. So the problem is with arrays of other types, we don't have that special character at the end, the /0, which incidentally has the ASCII value of 0. We don't have that at the end of the array. We've got exactly the right number of things in here. How do we know when we're at the end of the array? Is there some special trick? And the answer is there actually isn't. So what you could do, and you would need to keep a running total, because what if there are only 3 students that have signed up? You need to know you've got a bunch of space left. So what do? You've got to have another variable. So we could say uh, count of students signed up, something like that, and it starts at 0. Remember, we do need to assign it a value. There's no way we can rely on it starting at 0, so we need to say starts at 0. Okay, and then every time we add a student to the roster, we've got to add 1 to that value. So what was our shorthand for adding 1? It's plus plus, right? So we could just do that. Plus plus, plus plus, plus plus. So now we should be able to check. Oh, every time we add something, we could say, hey, have I got too many people in the class? How many spare slots do I have left? So you could do something like, let's say, int remaining free slots, number of free slots, number of free places is equal to 30 minus the count of students that have signed up. Okay, printf remaining seats equals something like that. That's okay. It's just saying I haven't used this variable yet. That's all right. And I'll run that, and it said remaining seats equals 27, which is perfect. So we've added 3 students. We know we've got 27 free spaces. What else could we do with that? Let's make another kind of loop. We'll make another for loop first, shall we? Let's just keep adding students in a loop. So we'll start with student numbers 30 and 0 in the class. Okay, so for let's do a different sort of loop. So actually not a for loop, because we want this to run forever and keep trying to add students 1 at every iteration until there's no space left. How about let's do that? So let's do a different type of loop, and there is a different type of loop in C called a while loop. A while loop will keep going until whatever is in the condition is no longer true, right? Okay, so what are we going to put in the condition? We're going to say while the count of students is less than 30. So this doesn't have that notation that the for loop does, where it splits it into 3 sections. It only has the middle part, which is the condition. So the first time you enter a while loop, and it's the same internals in here, do whatever lines are in execute, shall we say, in order, execute, whatever lines are in here, every time we iterate the loop, right? So before it does any iterations, it always comes up here and it checks if this is still true, okay? So let's say while the count of students signed up is less than 30, do another iteration. And I think every time we can just say a student has come up and typed their number in, right? So we could say student numbers, and then this is an interesting concept we're going to use. We're going to actually use the counter. So these 2 variables go together. We're going to use this counter as the index, right? Count of students signed up equals, and then we can make up a number here. Should we actually say, let's just say 1, 2, 3, 4 plus this number, just to make sure the numbers vary. It's not actually meaningful. We're just going to use this to add 1 to every number. You could make another variable to keep track of the running total of students, or create a random variable. There's a function called rand you could use to create a random number. But we won't get into that just yet. Maybe that's an exercise for later. Find out how to use rand to create a random student number as an integer between 1,000 and 10,000. So some sensible range of numbers that looks like a student code, right? Okay, so number of students signed up. Now, let's print, actually. Printf student number whatever just signed up for the class And then we can also say there are %I seats remaining free. Okay, so we have two placeholders in our printf. The first one is the student number that just signed up. So let's just grab this actually and paste that down. So whatever value we have just assigned into this array index, or the array element indexed by this number, whatever value we've assigned into here, you can treat that as a variable. It's going to print that out as an integer. Okay, so it should be 1, 2, 3, 4 plus whatever that was. So that student number is just signed up. And then we need the seats remaining, right? And we can make another variable here. Int seats remaining equals 30 minus the count of students signed up. Okay, I think that's correct. I often get my mathematics wrong, so let's just see. Okay, now I've forgotten to put something in there that's very important, but let's just try and run that and see what happens. It may very well blow up my computer, so let's clear this. And if the stream blows up, you'll know why. I don't think it will, but it's useful to demonstrate this kind of bug. Okay, so we're just going to run it, and whoa, it's printing over and over and over and over and over forever. And it said student number 1234, which should be our first student number, just signed up for the class. There are 30 seats remaining free, but it hasn't done anything beyond that. It's just always the same thing over and over. So what's it doing? You got to walk through to find your bug here. By the way, if you get into this situation, which is called an infinite loop, in most terminals, if you hit Control and then C, it will send a signal to say stop the program running. So that's stop my infinite loop. If you're running it within an IDE, there's often a big red stop button somewhere that'll do the same thing. Okay, so we've got an infinite loop problem. So the while version of the loop, while is, let's say, vulnerable to infinite loops. So you need to be really careful about this condition. And you probably know what I've forgotten to do, because we just talked about it at length. I forgot to increment the number of students that was being counted up. Now remember, the for loop does this magically for us over here. Whatever index we're using, it will do that every time. You don't need to do it manually inside the loop, but we're going to need to do that manually. So I'm just going to add down the bottom here at the end of the iteration, count of students signed up plus plus. I think I might be off by 1 there, because when the first student signs up, there should actually be 29 seats remaining free, right? So actually it should say 30 minus the count of students signed up. So that's not quite right. So I need to increment this before I get to that point, right? So 30 minus 0 is still 30. So that was incorrect. What I should have done is said student numbers equals blah, 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 and then said the count of students signed up after this point, after we've assigned a number, is now 1. It's not 0 anymore. And then I think it will make more sense. Okay, so it is said, oh, where did it start? Let's get rid of this, because that's confusing. And I think we can just get rid of this for loop. Now that we've talked about that, let's compile it again. Unused variable myString. Let's get rid of that. Okay, so it's done quite a lot of stuff there. It looks like 30 lines of output, so it's probably right. But there's definitely some problems there. So we got a first bug we need to go and hunt. So student number 0 just signed up for the class. There are 29 seats free. So that sounds correct, doesn't it? And you could see with a small number of things how you could sensibly walk through this one line at a time on paper. And so the second time it's gone through, student number 2, how many numbers is that? 268,501,009 just signed up. So that's clearly not correct. And I think that my values are fine because I'm just adding 1 each time. I think what I've done is messed up my printf somehow. So let's see here. Count of students signed up starts at 0. Where is it modified? Only here. Is it 1 is added every time? That sounds correct. That sounds correct. It's not modifying that variable. Why is it printing the wrong number? So student number Oh, this isn't my counter, it's the student number that's incorrect. So student number, and then seats remaining. Does seats remaining look correct in the printouts? 29, 28, 27, 26. Yes, so actually that value is correct. I believe the count of students signed up. Let's print that out too. Percent %I students are signed up. Second to last of those placeholders. Let's compile it again. So let's see. We're just checking that that value or that variable is okay, and then we're going to check the other variable. So 1 students is signed up, 2 students is signed up, 3 students. Okay, that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's perfect. So what was wrong with that first number there? So the first student that signs up should be 1, 2, 3 plus the count of students signed up. And you've probably seen what the mistake I've made is. So I've said student numbers, count of students signs up equals, and it is something we've talked about already, 1, 2, 3, 4 plus whatever this is. So this should be 0 at this point, right? If you do your walk, you'll see that this is 0 on the first iteration at this point. So it should be 1, 2, 3, 4, but it's actually printing out 0. So there's something wrong there. What is it actually printing out? So down here, we've got student numbers, and I'm quite happy that array looks okay. It's 30 big. So what is wrong with this index? So actually, by the time we print it, that value has changed. It's no longer 0, which is we assigned a value to index number 0. But we're not printing index number 0 anymore because this index has changed. I just incremented it. So actually, we're printing whatever is in index number the next one, and we haven't assigned anything in there. So those are uninitialized variables essentially, and whatever is randomly in memory at that point, it's going to print that. So if we actually draw a little diagram here and we say student numbers like we did with the string, so the first number that was in memory was 0. The next number, just by random chance, maybe whatever program ran before, put that in memory as the value. The next number is 0. And instead of printing the one we've just set, so the first loop iteration, we've set it to 1, 2, 3, 4 plus 0. Instead of printing the one we've just set, we're actually printing the next one because we incremented our count of students. So instead of printing the one we just set, which is index 0, we're trying to print index 1, which is this one here. And we didn't get to that yet. We haven't assigned anything there. So what we need to do is say, okay, let's print the count of students that sign up minus 1. So that'll print number 0 now on the first iteration. Okay, that looks better. So we've got student number 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, and so on. So that's how you can iterate over arrays, the basics of arrays, and some ideas about arrays and strings. And 2 different types of loops. So we had the for loop, which is your basic loop, which you should use for just about everything because it is a little bit less error prone than a while loop. There's a variation of a while loop called a do while. Okay, and it looks a bit different. And this is older C code will use these more frequently than a while loop. So you can say do some condition. Put whatever, you could put exactly the same stuff in there if you wanted. And then close the curly braces. Now the difference between a while loop and a do while loop is when you enter a do, oh, I think it needs to say while down the end there, semicolon. Let's compile that. What did I miss? Oh, maybe I don't need that. Statement with no effect. Oh, well, I'll comment this one out and then see what it thinks about the second option. Okay, expected. Maybe it's do. I thought that was correct. I might have the syntax incorrect. Let me just double check there a do while. C do while loop. I don't use these ever, so I need to double check actually. Oh, I have the condition in the wrong place. So the condition, oh, this kind of gives it away what the difference is actually. Okay, so you have a do while loop. Instead of while and then the condition, it just says the keyword do. and then at the very end we have while, the keyword, and the condition there. And the difference is kind of given away in the layout, that instead of at the top of every iteration checking if the condition is still true, it will always execute the first iteration, and then only at the end of the iteration will it check if a condition is still true, and if it fails, it'll stop. So it means that if you have an operation that always needs to work once, and then in some special cases continue doing iterations, this might be a convenient layout. I find these a little clunky, so very rarely do I ever use them. There are some cases where that is handy, where it's clunky to do a while loop. But yeah, that's just another alternative. So I think those are the only types of loops. I think those are the 3 loop layouts. Um, okay. Oh, I see. Super Megabyte there has told me what my problem was. Okay, so do while, another option, occasionally useful. Um, some people use that as their if you see older code, they'll often use that as their default loop type. So let's get rid of that actually. Do well. It's good to know about. So you can add that to your toolkit. If you're like practicing different loops and things and playing around, try and break them, try and get into infinite loops, and try all 3 types, maybe in separate programs. Um, so the other thing I can tell you about loops is there are 2 keywords you might find useful. And maybe you've got to some special student number that's like, I was wondering when that student would turn up for class. And you want to, I don't know why, maybe you want to stop at that student and put an alert on the screen that says, hey, teacher, check it out. This student turned up for once. Make a special announcement. And what you could do is there's a statement called break that will let you jump out of the loop without coming around back to the condition. So you could put more than one condition up the top there if you wanted to. We won't look at that just yet. It's possible to have several conditions. But there is a statement called a break. And if you put break semicolon, it will always stop when it gets to this instruction. I don't think we looked at branching logic yet, but we may as well do that immediately. So there is a statement called an if statement. So if open parentheses for condition again, if, and we can say, let's do it. Let's in fact do this right after where we assign the student number. So if student number of the student we just entered is equal to, let's say 1236 is the student we're looking out for. So is equal to, and we're not going to use 1 equals because that's assignment operator, and that will accidentally assign a new number over the top of the one we just assigned, and we don't want to do that. So for a quality testing operator, it's 2 equal signs. So what we're saying is if that student number and the value in the variable we just set, or the array element we just set, is equal to 1236. Okay, then we can open new braces. And actually, we're going to print something out. We're going to print, hey, teacher, 1236 just turned up, exclamation mark, something like that. And then afterwards, break, and that will stop the loop. So it will no longer sign students up for the class. So if I compile that and print it, so that's 2 new concepts. That's a break, so it's like an escape hatch, or if maybe you want to check that some counter hasn't gone too far, so you don't use up too much memory or something like that. Or wow, it's gone for 6 days. I want to stop the loop for sure now, even if otherwise it would still process valid data. Stop it because I want to do other things with my computer. So you can have a little escape hatch with an if statement and a break, and that will cancel the loop iterations and jump the control flow from here where the break statement is to the end of the loop. So right after where the loop finishes. So normally control flow line by line by line. When we've got a loop, it will check a condition, and if the condition is true, it will jump back to the start of the loop and continue normal control flow from there. With an if statement, what we're doing, when we get to this isn't going to execute anything. It will do another expression test. So test this condition. If that is true, if that evaluates to a true answer, it will jump the control flow inside the braces of the if statement and proceed as normal. If it is not true, it will skip the if statement and carry on down below. So that is a way of adding in additional conditions. And you can do if statements wherever you want in your code. You can have if anything you want, the result of an arithmetic expression, if 1 plus 1 equals 2, for checking if 1 plus 1 are equals to 2. So you could do this. If 1 plus 1, and that is always going to be true, so you always jump into that if statement. Usually you're doing things like this, where you're checking for the value of a variable to see if some particular value is set. Maybe it's an invalid number for whatever you're going to do next. Just a little escape hatch to say, whoa, skip this next bit. So teacher just turned up, and it did actually print that out when I ran it. So it did the first two numbers, 1, 2, 3, 1, 2, 4 student numbers. When it got to that special one, it printed this and then broke out of the loop. So it didn't keep iterating. Even though this condition was still true, it ignores that and jumps straight out. Break, jump out of loop. Okay, there is another special keyword you can use in a loop, which is quite handy. And let's just comment out break for a second. There is a keyword called continue. And continue, instead of jumping out of the loop, it will jump back to the beginning of the loop. So if there's some special student and you don't want to do something with, maybe don't complete their sign up, or maybe they don't need a seat. So maybe they have a foldable chair they always bring with them, so you don't need to subtract the number of free seats. You don't need to worry about that. So you've got a statement called continue, and if you get to a continue within a loop, it will jump to the start of the loop. Okay, so this should keep going. One thing we do need to do though there, let's do it anyway. Let's just compile and run that. Oops. Okay, hey, and it's continuing the loop. However, we forgot something. It's just repeating on and on and on because we forgot to increment this number. So if you remembered, we've got plus plus, because it's normally incremented down here. So we need to put that inside our if statement before we continue from the top. Otherwise, a for loop will increment, but this while loop will not. Okay, perfect. So that should give us, hopefully that gives us 31 students in total. So that's a nice little extra keyword you can use. Not always useful. Just occasionally there's some special piece of code and you want to skip the rest of your for loop. The rest of your loop iteration. Okay. So actually, before I do that, what you could have done if you wanted to save a line, although this is getting dangerous. In fact, no, we don't want it in the if statement. What you could have done is incremented up there instead. But actually, if the if statement fails, it's still going to have incremented the counter by 1. So we'd get rid of that. And then it's very confusing to follow, actually. So let's not do that. So making code choices when you're coding about making it easy to follow logically is usually the right way to go, rather than trying to save a line or something like that. Okay, cool. That looked like it worked. Back to our break there. And I guess the only other thing I didn't mention is now you've seen more of these curly braces. Remember I said when we were looking at functions, we said that functions have their own scope. So variables in one scope don't look into other scopes, and that has come up again here. So we don't have functions, but we have loops, and we have if statements are a type of condition. So we have 1, 2, 3 different types of things with curly braces. And please always put these curly braces. They're a really handy reminder. If you have a little one-liner statement in here, like just break, and you leave out the curly braces, that will be the same as if you had this, right? So some people do not put braces around their one-liner statements and loops and things. I strongly suggest you always put the braces because it's really easy to make a mistake and then do another line in there and forget actually, oh yeah, it didn't have a brace, and then it doesn't work the way you think. Yeah. So I always, as a rule, even if it's just a one-line if statement, I will always put these braces because if no one else does, I will screw it up. So if it just had printf, right, it would be totally valid. It would work the same way. as if you didn't have the braces. But later on, I'll go down here and I'll go, oh, okay, let's do break. And I will think that I now have two things in my if statement, but I do not have two things in my if statement. That is the equivalent of this layout, right? So the break will never happen in the place you think it does. It's the same as that. So I always, as a rule, put these in just as a reminder to myself of what the actual stuff inside the statement is going to be, because your code is flexible and it will change. So it's a good idea to plan in advance for any change. It might be fine now, but when you're tired at 3 a.m. or something in coding and you put one more line in, it can go horribly wrong. So I like to add a little bit of an insurance policy so 3 a.m. Anton doesn't screw it up, or I don't screw up anyone else's code at 3 a.m. Okay, so coming back to scopes, you'll notice that we now have lots of different things with curly braces, and I said curly braces, where they're used explicitly like this, and please always do for this reason, they indicate scope as well. So if I made a variable inside my if statement called int Anton's special variable equals 123, I could print that out here, no problem. Let's just add that to that printf, comma after the quote. Anton's special variable, it should work. I think that should work. Yeah, so it's printed 123 at the end of that print statement. That's fine, but I couldn't print it down here in this other print statement, and why not? So I'll add that to the end of the list, the long list of parameters or arguments printing there. So it said, hey, Anton's special variable is undeclared. But that can't be true because on a line above this, and we've declared it, right? Well, it turns out that the if statement has its own scope, and everything inside here is only visible to things inside the scope of the if statement. So everything in between the braces is only visible or in scope to the things in here. It's still in memory because we're still inside the same function. So it technically should still be reachable memory, but we can't access it because according to the rules, it's not in the scope. So if we wanted to use that in both places, we would have to put that into a higher level scope that's common to both things. So I could have put that here, and that would be fine. Right? So now both of those print statements can access that same variable. And there are rules about, oh, I should have lined that up. There are levels of scope, which is why I'm quite fastidious about indenting things. So inside the main function, everything is indented one level. But when I get to my while loop, which you'll notice has a new brace or curly bracket, everything inside the opening and closing new braces is indented one level again, right? And then when I come down to the if statement, which has yet another one inside these other ones, so this is now braces within braces, I've indented again. So you have levels of indenting. And it doesn't mean anything. It'll compile just fine if you leave this over here. But it's a hint to the person reading it that everything on the same vertical line is actually in the same scope. So the things inside here, they can't, if I declare a variable inside this indentation level, it can't be used in a level higher. You can, however, access things from a higher level scope. So things in this more left-hand side indentation or inside the surrounding scope, that's fine. I could access that, and I do access something from the while loop scope inside the scope within a scope. Okay, so you can have scopes within scopes within scopes within scopes, as long as they are inside another indent level or another level and being surrounded by another scope. So that's kind of a complicated idea, and the only way to really do this is by practicing stuff like this. So actually make a program and fiddle around with the scope and see where and where you can't access a variable. I thought that was worth mentioning now that we have a ton of these curly braces lining up for different things. We have another type of scope, which I didn't mention, actually, that has nothing to do with arrays and loops and counters and things like that, and that is global scope. So if you have functions, so void Anton special function, and this is just going to say printf Anton is %i years old, comma, Anton's age. Okay, so what if I wanted to have a variable called Anton's age that I access somewhere in main? So let's print that in here as well somewhere. Okay, so I want a variable. Anton's age equals 101 years old. Okay, so I've got this variable. I want to be able to access it in main. I also want to call this function and access it there too, right? So I want to print this twice from different places. Maybe you do different stuff with it in different functions. That's fine. But I want to be able to use it in both places. So what I could do is add a parameter in the input to the function called Anton's age. Send it in as an input to this function, and then grab it here as a parameter, int age, and I'll call this age, right? So that's a way of copying the value that's stored in this variable into another variable as an input to this function. So they're not the same variable. I can't actually modify Anton's age from inside here. That's kind of a pain. One way to deal with that is, okay, let's scrap that idea. What if I really do want to be able to modify that variable from two different places? So Anton's age equals 102, actually. So let's see here. How do I get hold of that? And one way to do that is to put it in a higher level scope. And functions will respect a scope called global scope. So if it's not within a function, you can just have it floating around here in the endless void, out in space, not within a function, right? And it's possible to declare and initialize all on one line. You can't have any actual code instructions here. So you can't say Anton's age equals 101 here. That won't work because only main is the entry point that starts executing stuff. So the compiler will not let you do this line, but it will let you assign an initial value to something, and it will let you create variables in what's called the global space. So this is the infinite space surrounding the Earth, and everything, every function, and in fact, at the moment, if we had more than one file, every file would be able to get the definition of this variable and modify it from different places. So if I print that out, it said Anton is 101 years old. That's this first instruction in main. It has jumped down to this one. Oh, I actually didn't need to give it a variable there. I should have put void there to stop me accidentally giving a variable. Void's a nice little trick to say, don't accept any inputs. C will let you put inputs to something that doesn't have void and not complain, which is bizarre. But if you put void, it means, no, really, don't give me any inputs. See, it said that's incorrect. So now I can get rid of that. So void's a neat little trick you can use. So yeah, now what it's done, if I compile that again and run it, it said Anno is 101 years old. It's printed the original initialized value here, right? And then it'll jump into my function and then actually modified that same variable and printed that out. So actually, if I print after the function call, it should retain that same value. So 101, 102, and then jump out of the function back to main, 102 still. So it has actually modified that variable from two different places. Well, in fact, if I say Anton's age equals 20, it should now be modifying that from two different places, same memory. And that's kind of handy for small programs to use some global functions. People get very upset if you use a lot of global functions because you quickly lose track of stuff. But for your small initial programs, that's a really handy way of sharing variables between functions without doing input, output, input, output. The more tedious way to do that when you're starting is to go int age, and we'll also return it. So we'll say age equals 102, print age, and then also return age. And then when we call the function, we go Anton's age equals Anton's function. And what that's doing there is it's saying, okay, I have a function. It takes my existing age as an input. It sets a new value and then returns that age as an output. And then wherever I've used that variable, just change the value to the output of this function. So you've got the job of any function is to take inputs, convert the data, and spit out an output. So input, output, and the function does that sequence of stuff that maps the input to some new output, right? Most of the time. So, okay, the output I'm going to use in that same variable. So I've given my existing variable as input and then modified that same variable with the output. So that would be a little bit more tedious way of doing this without using a global. It just means that you're copying. Oh, Anton's age is declared int Anton's age. Right. So now we're not actually modifying the original variable in the function. We're generating a new value. So we're doing what's called copy by value. We're not getting the original variable. We're making a new variable, and the same value from the input was copied into this new variable. So we actually have two integers there: the original one and the one the function sees. And we're finally returning a value as output, and then finally assigning that back. So that is parameters are copy by, sorry, what's the, that's not the quite correct parlance, but my brain's slowing down there. Parameter is copy, the value of the parameter. Let's just say that. The value of the original variable is copied to the new variable called age, right? So that's kind of a nice concept. Pass by value, sorry, that's what it's called. This concept is called pass by value. So what that means, pass by value, means you don't actually modify the original variable. And using a global variable is one way to get around that, so your function can actually modify the original as well without needing this whole parameter thing as an input. Little bit untidy, and people get very uptight about using global variables, but it's completely fine for simple code. Yeah, I think much later you can come to why it's nice to reduce the number of global variables, but you don't need to worry about that at all when you're starting. Cool. Okay, so that is, just to summarize, we have done, let's get rid of this. We have done for loops, which look like for, and then initial condition when the loop starts, create a variable, assign a value. You can actually do more than one value if you want by putting a comma. So you could have a different counter that starts at 2. So now I have I starting at 0, j starting at 2. That's completely possible. The second, after the semicolon, the next clause is what happens at start of every iteration to check if you should do another iteration. So I less than some value. And then finally, what should you do at the end of every iteration? And in fact, I++, add 1 to I. And in fact, you can have several things there. So if you had a j as well, you could go j++. Right, with a comma separating them. That's completely okay. You can also subtract 1 every time. So when there's plus plus, there's minus minus. You can have a loop that counts down to some value. That's completely okay. And if you're playing around, you should try that too. It's a little trickier to get right, and it's easy to go off the end in the other direction of the array. And it has braces, and then all the statements inside the for loop get executed one at a time. You have while loops and do while loops, and they look like this. While something is true, so you could have, if you wanted to recreate your for loop, you could have above here, because we don't have an initial condition, what I equals 0 to begin with, and then while I is less than some value, do your loop, and at the end of your loop, I++, right? So it's a little bit trickier, a little bit more susceptible to issues if you forget to increment things. So actually newer languages don't have while at all. They only have for loops, or only have a different type of loop we don't have in C called an iterator. And we have some keywords that are handy. Break, continue. We also did if statements. If I is less than some value, any condition will work here. You could have I equals some value, if I equals some value. So we looked at the equality operator, which is this one here with 2 equal signs. Don't accidentally ever do I equals, because you might assign something instead, and it looks like your program still works. Most compilers should warn you if you do that now, but some might not. You never know. Turn your warnings on. It's a very easy mistake to make to forget one of these. If I equals some value. Um, we also have scope rules. Um, scopes within scopes within scopes. Use indenting to help identify scopes. Always use braces around scopes. And we looked at global variables. Actually, the first thing we did was looked at array declaration, which is int my array of size 10, or char my string of 5. And we looked at initializing variables and array elements. So my array 0 equals 10, or string literals, which is my string, which you can only do when you first declare a string. So my string, Anton is great. We also mentioned that the last character in a char array string must be /0 to indicate where the end is. And actually, if you do a string literal, it will add that in for you. But actually, we need to be careful here that we leave enough space. So this would actually require 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, because there's an extra one for the /0 at the end. So size 16 should work. Actually, the editor was warning me about that. If you do a literal like this, where you've explicitly said what's in the array or the string, you can actually leave this out and the compiler will work out how much space that you need. And it will do it exactly to fit your string there. Okay. I think that's kind of everything I wanted to talk about today. There was one more thing I was going to mention, but I'm sure we can pick that up again later. But definitely do play with strings. You've got to play with loops to get the hang of them and see. They're very tricky. It's very easy to lose track of the things you have in your array. So go off the end of an array, go off the end of a string. One neat little trick you can do if you're reusing this value here, no, you don't need to put a null terminator into my string there. So you could do this. Whoops. And that would, I guess, try and add in a character there. You don't need to do that when you do a string literal, like this with the quotes, and it will do that automatically for you. The compiler will add in, when it compiles it, your extra character in there. It'll add a 0 on the end. If you're assigning character values one at a time or modifying a string by manually changing some characters, you absolutely do need to put that character in there somewhere. So create a variable to keep track of the current number of things in your array. We did that with student numbers. But another thing you can do is use the preprocessor. If you need to reuse this value 10 here, you might think, okay, I'm going to do max array length equals 10, right? And then use the variable in there. So in other languages in here, perhaps in here, in other languages that would be okay. In interpreted languages, that's probably fine. But C doesn't know how to deal with that. It wants to allocate all the memory for an array when it compiles the program. It wants to know that in advance. So this is done at compile time. It's not dynamic. It doesn't run the function and then go away and find out how much space it needs as you use it. You need to tell it up front your maximum size. And this is one tricky bit with C that people find a bit difficult. You get the hang of it. And the trick is to just always make your arrays bigger than you think you need. So maybe the biggest a string I ever think I'm going to need is like 512 characters, perhaps. My biggest array, let's say I've got 30 spaces in the class. Let's make it 64 or 60 or something, or 100, right? And there is a nice little trick you can do if you can't use what I was going to get to is you can't use a variable. It won't let you. So if I try and do this, the compiler will complain, actually. Um, you can give a hard-coded number that doesn't ever change. So you can't dynamically change the size of your array while the program is running. It's fixed like that every time you run it. It's always going to be that size. This is static memory allocation, essentially. So create that space. It has to be that big. The compiler has to know. It won't do it when your program's running, which is called at runtime. So what you could do, if you need to reuse this value kind of as a variable, it would be handy, because if I want to change this to 94 or something later, then I'd have to go and pick through, and every time I've got my maximum size, change every one of these, and I'm always going to forget one, and then I got a bug that blows up in an unexpected way. So what you can do is use the preprocessor to do that for you. So you can do something called a hash define. It's kind of like making a variable, but it's really just doing a text substitution. So I'm going to say max my array 10. And then every time I use this um, sequence of characters, and I've done it in capitals to indicate this isn't part of the C language. It's not a variable. It's something from the preprocessor, and that's a nice convention to use to separate your variables in lowercase from some constant thing that works differently in uppercase. So you're not allowed to set. You're telling yourself, this is not a variable I can modify. It's some fixed thing. And I'm just going to use that there and there and there. And what will happen is before the compiler gets your program, the preprocessor will go through first and it will go, okay, I'm going to include this file. We'll paste that in here. And then what we're going to do is every time I see this in the text, I will go look for this. And there's 1, 2, 3 instances. I will, before the compiler gets it, replace that with the number 10. Right? So it's doing the difficult, buggy bit, error-prone bit for you. And now you can use this as if it was a variable, but it's just a text substitution, really. So that's a handy thing to do for array lengths. So you will get this pattern a lot where you need to iterate over something up to its maximum size. And if I ever need to change this to 94, I only need to do it in one place. I don't need to do it in several places in my code. So that's kind of nice. So I think that's kind of all I wanted to talk about today. It's not all the detail you need to know about loops and arrays. So definitely do go and read a little bit and make some practice programs and try a few things out. And even the For Dummies book could be a good one for a bit of, if you don't want to get the official C book, if it's too expensive or you can't get a digital copy. Have a look at the For Dummies, which you should be able to get a digital copy of. That should give you a pretty good list of all of the rules for all of these different conventions and a little bit more detail. But that should at least be a starter of the concepts. Okay, so unless there's some questions or any random ask me anything kind of questions, I guess that's all we're going to do. And then next time I'd like to do some memory allocation, or you really can change the size of things at runtime. I'd like to do some file input output and then maybe writing out an image if we can fit it into an hour. Okay, it looks like that's about it. So I'll stop the stream, but I'll jump on the chat if something occurs to you afterwards. Thank you, everyone.